So we know that when you differentiate a function and substitute in an x coordinate, it gives you the gradient of a line at a given point. So if that gradient or if that derivative is greater than 0, we know that our function must be increasing. If it's less than 0, we know that it must be decreasing. It would be a negative gradient. So this first example is asking us which values of x is that function increasing. So for that function to be increasing, dy by dx must be greater than 0. So in other words, it needs to be a positive gradient. So I would always make sure that you're writing out a statement like that at the beginning, so it'll help you understand where you're then going from there. So we need to find dy by dx. dy by dx is 3x squared minus 12. Now for that function to be increasing, we're trying to find the values where it's increasing. We're saying that that has to be greater than 0. From there, you then need to factorise it. So remember, always look for a common factor. So take out your 3. We're left with x squared minus 4 is greater than 0. Now that's not a trinomial, but it is a difference of 2 squares because 4 is just 2 times 2. So we can keep going and split that into x minus 2 and x plus 2 must be greater than 0. So think back to your polynomials topic. We can now put this into a sketch so that we can find our inequality. So we've got our x and our y. Our roots here would be negative 2 and 2. We have a positive x squared, which means that it's a minimum turning point. So it looks like this. So we're looking for where this graph is greater than 0. It's greater than 0 here. And it's greater than 0 here. So remember, when we're talking about greater than 0, we're looking for where it lies above your x-axis. So we can see that it's greater than 0 when x is less than negative 2 and when x is greater than 2. So the function's increasing when our x values are smaller than negative 2 but greater than 2. This next example is a little bit different because it's now asking us to explain why a function never decreases. So if a function never decreases, it means that it's always either increasing or stationary. So it's always either greater than or equal to 0. So if we can prove that the derivative of that function is always greater than or equal to 0, we can show that it's never decreasing. So our derived function f dash x, is 3x squared plus 6x plus 3. Now, we want to show that that is greater than or equal to 0. So the first thing that we're going to do is factorise it. So when we do that, we can take out a common factor of 3. We're then left with x squared plus 2x plus 1. That can then be further factorised down to splitting up my brackets into x and x, 1 and 1, plus 1 and plus 1. And I can rewrite that as 3x plus 1 squared. Now, given that I'm squaring this point here, that is quite clearly always going to be greater than or equal to 0 because no matter what number ends up in this bracket, whether it's positive or negative, you're always going to end up with a positive. So that means that that's always going to be increasing or stationary. So since f of x, our derived function, is greater than or equal to 0, our function never decreases. It's always increasing or stationary.